All right, we're back. We're on page 5 of notes 5, and it's the last page, and it looks like it's mostly review. So I'm going to go through it kind of quickly, maybe. The graph below is the derivative f prime of x of a function f of x. I adopted that because the AP exam just like always does that. It points out that a graph is the derivative like 58 times. And still people confuse it. But anyway, we're looking at f prime. F of 3 is -1. Use blah, blah, blah. Let's do this. Tangent at x equals 3. So I know f of 3 is, so f of 3 is -1. F prime of 3, we can go up and read that. F prime of 3 is 2. And so that's about it. So our tangent line is going to be y minus -1. So y plus 1 is 2. X minus 3. That's it. Solve the equation f of x equals -1 on the interval -3 to 11. So, I mean, f of 3 is -1. That's just given. So x equals 3 given. All right, now what are we going to do? So basically, I'm going to look for symmetric areas. So here, for example, if I go this way, I don't even need to know what that is. I mean, I guess it's 3. That has an area of 3. This is on the opposite side of the x-axis and also has an area of 3. So these are going to cancel. So I'm going to say that the integral from -3 to 3 is 0, because it is. The integral from -3 to 3 of f prime of x equals 0. Therefore, f of -3 is also -1. So that's another place. So therefore, x equals -3. So I mean, another way to think about it is you start here where the value of the function is -1, and then you lose 3 going this way. So the value here would be -4. But then you gain 3 going this way, so you're back to -1. So like just a different way of thinking about it. Then we gotta go the other way. Well, potentially. So this region, which is really, I'd say coloring is not like my strong suit, maybe. I don't know. Well, no, I mean, it's definitely not. That region and then this region, oh, I'll let it go. I hate the overlap look of the highlighter. So like I insist that I always do everything in one shot, which, you know, there's no reason, but I do it anyway. All right, so the integral from 3 to 10 is also 0, which means that f of 10 is -1 as well. 3 to 10 of f prime of x equals 0. Therefore, f of 10 is -1. So x equals 10. So I get 3 different values. State and classify the critical numbers of f of x. So that's where the derivative is 0 or undefined. It is never undefined. It is 0 at 0 and 6. I mean, also at 11, but usually that's an open interval, and it is. So 0 and 6. So let me write those. Critical point at x equals 0, x equals 6. Now, what is the function doing? So at 0, the function is going from negative to positive, the derivative, I should say. It's going negative to positive, which means that the function has a minimum. So f of x has relative minimum at x equals 0, because f prime changes negative to positive there. So this is the kind of review that you want to do as you're like, well, I'm talking about people in AP Calculus, but like if you're in AP Calculus, you always want to be doing this kind of review because you have to know everything, and it's like really hard. That's not 6 at all. That's 6.5. Look at that. People just like to forget things, right? Like your math education up until this point seems for worse, not better or worse, just worse. Always just let you forget things. But here you don't have a choice. You have to know everything all the time. And it's a little overwhelming, but not if you keep up. So 6.5 the function changes, the derivative, I should say, changes from positive to negative. So 6.5, got to make that change. Which fortunately I put a period here for some reason, 6.5. So f of x has a relative maximum at x equals 6.5 because f prime changes positive to negative. Positive to negative, there, boom. Okay. So this one I'm gonna like do first. Well, maybe I'll do u. Should I do u substitution? Let's say if u is equal to 2x, when x is 5, u is 10, and when x is 2, u is 4. So this is gonna be, and then du, so 1/2 du is dx. So we get the integral from 4 to 10 of f prime of u du. All right, so do we know that? Probably not, but we could probably figure it out. 4 to 10. So the integral from 4 to 10 of f prime is going to be, it's going 4 to 10. 4 to 10. All right, so I see some symmetry here. I'm going to erase the highlighting that I've already done. So we're going from 4 to 10. All right, 4 to 10 is like this. So here's the thing to notice. This part and then this part are exactly the same size, but have opposite signs. So that's just going to cancel out. So right now, when we get to 9, we're sitting at 0. Like we have nothing so far. And then if I go from 9 to 10, I just get -2. So 9 to 10 is what I'm actually looking at. That's -2. So I think that this is going to be 1/2 of -2, which is -1. Hope I'm doing these right. Got no one to check them, so like, nah, who knows? Use your calculator to find the value or values of c guaranteed by the mean value theorem for the function f on the interval from 0 to pi over 8. Show your setup. All right, so mean value theorem, I'm going to say that f of x is continuous on the closed interval and differentiable on the open interval, because that's the requirement for the mean value theorem. So therefore, by mean value theorem, f prime of c, we're going to solve for c, is equal to f of pi over 8 minus f of 0 over pi over 8 minus 0. All right, so now we just need to like work that out. For some, well, I should say for some c between, for some c, that's an element of, what if the microphone is picking up the fan? The fan is out of control on my MacBook right now. Because it's like pretty hot, I guess. And also I let the battery get really low, and that probably wasn't a good idea. Let's see. All right, so I'm going to define the function, call it f of x. I'm going to put a new problem, doc 4, and then option 1. All right, calculator, f of x is 3 sine of 2x plus cosine of 4x. Okay, and then we got to do this derivative thing. So let's see if we can just solve it. Solve derivative f of x comma x. So that'll find the derivative. I want to set that equal to f of pi over 8 minus f of 0 over pi over 8 minus 0, but like you don't really need that, comma x. And then it's always a good idea to actually limit this. Pi over 8. And I'm going to control enter. So it gives me a value, but it's probably telling me that more might exist. No, it's not. It's saying approximate arithmetic. Let's do the graph thing and just like confirm. There's always like, you just got to get nervous about that answer, right? Like f of pi over 8 minus f of 0 pi over 8 minus 0. Okay, and then also I need to graph the derivative of f of x. And then I'm going to change the window so that I can only see from 0 to pi over 8. Like I can see there's a lot of values that would make it true. There's definitely only one answer, so I'm going to use the numerical value that I was given. So I'm going to say, so I'm back on the notes, but therefore C is approximately 0.188, I guess, 0.188. And let me show you what that looked like, and then I'm going to call it quits on this, and I'm going to let my computer take a break here because it is really loud. All right, so that's my answer. So this is all review, but in the notes in general, we learned the integral test, which is like a really particular test. Like you need your function to be positive, decreasing, and continuous, decreasing being the really annoying thing to prove. And then your improper integral and your series do the same thing. Then we noticed a pattern in some of the problems, and from that we said, let's just name this series. So we came up with P series, 1 over n to the p, converges if p is greater than 1, diverges if p is less than or equal to 1. So that's what the notes were really about, and then we just did some review. So anyway, I'll be back at some point in the next video, and we'll be doing something different. So I will see you there.